Dr. Baker made a video about inulin, which is a type of dietary fiber that's added to foods. And I thought it was very fair, and the question was very fair, which was, does dietary fiber cause cancer? Now, what you'll find out from the research, which I'll go over as I go over an article about the research, I think Dr. Baker was very fair with how he covered this and actually very accurate. I'm going to play his video, and then I'm going to basically go over the information about dietary fiber, about liver disease, about liver cancer, to answer the question, does dietary fiber cause liver disease? And which I think is actually a very important question. I mean, it really is a very important question. Does it cause liver cancer? Does it cause liver disease? Apparently, in certain circumstances, it very well can, but we're going to see what those circumstances are, because it's a little different. It's not exactly what you might think, but it is very important, especially with the amount of refined foods on the market with added fiber to them. A lot of foods have added fiber. I actually appreciate that Dr. Baker covered this, and I do think he was very fair with how he covered this, and I'm going to hit play now.
Okay, does fiber actually cause cancer? That's an interesting question. And I've said many, many times that I think fiber is non-essential. I think its benefits are mostly conditional. And usually that condition is you're already on a standard American junk food diet, and then adding fiber in that situation potentially could be beneficial for a number of reasons. But can it be harmful? And if you see my other video on fiber, there are some potential harms with fiber, but this is an interesting new study that just came out suggesting that potentially fiber, particularly processed fiber, that is fiber that's been added to foods, can be linked to certain types of cancer, in this particular case, liver cancer. And you know, what they utilized was a compound called inulin. Inulin is a naturally occurring fiber that is found in a number of different plants. It's particularly rich in something called chicory root, and they'll often take this inulin from various sources and then extract it and then re-add it back into various foods, such as yogurts and granola bars and cookies and baked goods and drinks and all kinds of things. They add that to beef up the fiber content of this food, because we're told we need to eat.
Now, what I want to be sure that people understand, what I do find comical about the adding of fiber to foods is particularly with vegans. If you're following a vegan or even a vegetarian diet, because keep in mind, a lot of the foods that this is being added to are things like yogurts and granola bars. And as you saw, like he showed, you can just buy an inulin supplement. If you're following either a vegetarian or a vegan diet, do you really need to beef up your fiber any more than what you're getting with beans? I get well over 100 grams of fiber every day with my basic diet, okay, just from the legumes. Of course, I do follow a much healthier version of a plant-based diet than most people, and most of my foods are unrefined. However, there's nothing stopping the average vegan or vegetarian from following a diet exactly like mine, except for the fact that they don't want to. But let's let Dr. Baker continue.
Too much fiber. What turns out, at least so far in animal studies, it has been linked with increased rates of liver cancer, particularly if those animals have issues with bile salts, that they produce too much or don't absorb them correctly. And so this is an interesting little wrinkle on this sort of thing. And, you know, we have this sort of one-size-fits-all diet, get as much fiber as you possibly can, which certainly I've questioned on many occasions. I don't consume effectively any fiber and haven't for, you know, nearly or more than half a decade, and done just tremendously well without it. And so interesting to think that fiber could actually be harming you and leading to cancer, at least in certain situations. So let me know what you guys think. What are your thoughts on this? You know, in general, you shouldn't be consuming processed food anyway. And again, this is yet another...
See, and it's important that he notes that, because what I think the issue is actually consuming this soluble fiber without the addition of the phytonutrients or the insoluble fiber, which you will see when I read the article. That's what I think the issue is that there's no phytonutrients and that there's no essentially there's no, what do you call it? No insoluble fiber with it.
To not consume the stuff that they are pushing out there. They're feeding you this cheap, fake food, this human-grade pet food. It's not even human-grade, quite honestly, fit to feed your dogs in a lot of cases. So, food for thought, guys. All right, we'll talk to you soon. Bye-bye now.
So one of the things that you'll find is these animals, these mice, had dysbiosis to begin with. They were made to have dysbiosis to begin with. So that's something that you want to keep in mind. But so this says we were told that dietary fiber is good for us, but are all sources and forms of fiber equally beneficial to health? Studies by researchers at the University of Toledo, Utah, have surprisingly found that mice developed liver cancer when fed on diets fortified with refined soluble fibers such as inulin, as a probiotic that earlier, it's actually a prebiotic, that earlier this year the FDA approved to be marketed as health promoting. And it is health promoting in many ways, but the research, and I'm going to go over other things about the benefits of fiber, and do I think fiber is causing liver disease or liver cancer? Absolutely not. Okay, the research headed by Matam Vijay Kumar, PhD, Director of Utah Microbiome Consortium, and research and associate professor in Utah. One of the reasons, I'm going to stop reading right here for a second. One of the reasons I stopped taking probiotics and started eating prebiotics and focusing on having a lot of prebiotics in my diet is dysbiosis. If you're taking, and it's the same thing that's caused by antibiotics. When you take antibiotics, it can cause a dysregulation of the bacteria in the digestive tract and all throughout the body. The same thing can happen when you take probiotics, which is why I just started eating prebiotics, which foster the growth of the proper bacteria. So, Utah Department, and there's more that we need to learn about the microbiome before we start saying exactly what is the right this and the wrong that and what have you. But the Department of Physiology and Pharmacology was originally designed to investigate whether a diet enriched with inulin might help to combat obesity-related health issues in mice, and the results did show that inulin-rich diet helped to reduce obesity. So it does reduce obesity levels in the mouse model. But the experiments also found a clear association between dietary inulin and the development of liver cancer in mice that had altered levels of gut bacteria. So this is what you have to understand, that had altered levels of gut bacteria that could ferment this type of refined soluble fiber. So these mice already had dysbiosis. You have to understand that. Their bacteria was out of whack. But people have dysbiosis. Okay, so keep that in mind. The discovery puts a question mark over the practice of adding refined fibers to processed foods, the authors suggest. The results shook us, comments Vijay Kumar, reporting their findings in Cell. Dysregulated microbial fermentation of soluble fiber induces cholestatic liver cancer. So the authors conclude benefits notwithstanding, enrichment of foods with fermentable fiber should be approached with great caution, as it may increase the risk of what's that called? Hypercholesterolemia, whatever. Westernized diets, it increases your risk of liver cancer, hepatic cancer. Westernized diets typically include increased amounts of processed foods that are high in fat and sugar. So this is a processed food issue, if you ask me. In parallel with reduced consumption of grains, fruits, and vegetables that are naturally high in fiber. The authors explain that this dietary trend has been linked with a well-documented increase in the prevalence of obesity and related metabolic diseases. One seemingly local and practical approach to counter some of the unhealthy effects of Western diets might be to enrich processed foods with plant-derived fibers, the researchers suggest. Dietary fiber comes in two basic forms, soluble and insoluble. Soluble fiber can be fermented in the gut. Insoluble fiber just moves right through you. They set up the study to see if the refined fermentable fiber inulin and the resulting bacteria and bacteria byproducts generated might prove effective against metabolic syndrome in the mouse model of obesity, and the results confirmed that adding inulin to their diets did reduce adiposity, meaning body fat, in about 40% of animals, compared with adiposity observed in mice-fed grain-based diet. The inulin-fortified diet was also linked with improved glycemic control, meaning their blood sugars were more stable. However, adding inulin to the animal's food also had the highly disconcerting effect of inducing cholestasis, leading to HCC in mice that were kept on the diet for 6 months. Mice that were prone to HCC, meaning they were prone to it, exhibited gut-altered microbiota. So these are mice that are prone to this. They did this on purpose. But some people maybe also, or dysbiosis, characterized by increased fiber-fermenting bacteria. So these are special mice. These are not everyday mice, okay? The possibility of an association was strengthened by the finding that inulin-fed mice that were treated using broad-spectrum antibiotics to reduce gut bacteria didn't develop the issue. So germ-free mice that completely lacked bacteria were also free from liver cancer after being fed an inulin-enriched diet. So it has to do with the dysbiosis. And it's a lack of the other fibers and too much of one fiber. So striking, okay, I'm going to move on. A higher intake of whole grains and dietary fiber are associated with lower risk of liver cancer and chronic disease. Okay, keep that in mind. So we're going to skip to the end. Now, this study was done in people, which automatically makes it better than the mouse study, but keep this in mind. So this is from whole grains, though. This is not inulin, okay? So a total of 290,484 men, 59.8%, and 195,233 women were included in this study. The mean age of the study, so this is a better study, I think, and this is also not, but this is a different kind of study, as these people don't have dysbiosis and such, and blah, blah, blah. The mean age at the study entry was 61.5 years old. The majority of the participants were white, and 39.8% had at least a college degree or higher. Participants in the highest quintile of whole grain intake, or total dietary fiber intake, compared with those in the lowest quintile, were more physically active, had lower alcohol and tobacco consumption, and were more likely to have self-reported history of diabetes. Similar patterns were also observed for men and for women. Whole grain dietary fiber intake and risk of liver cancer. After a median follow-up time of 15.5 years, a total of 940 participants developed primary liver cancer. Whole grain intake was associated with a 22% risk reduction. So that's 22% risk reduction of liver cancer. After multivariable adjustment, the total dietary fiber intake was associated with a 31% risk reduction. So that's, again, total dietary fiber intake was associated with a 31% risk reduction. For different sources of fiber, significantly inverse associations were observed with vegetables, probably also due to the phytonutrients, and grains. Again, there's phytonutrients in grains, but not for fruits. Because remember, fruits are high in what? Fructose. I've already been over the danger of hepatic shock from high levels of fructose. The inverse associations for total dietary fiber and fiber from vegetables were observed for men and to a less extent for women. Significant inverse associations were found between total dietary fiber and fiber from vegetables and the risk of liver cancer. In stratified analysis, the inverse associations of whole grains and risk of liver cancer were generally observed in different subgroups. Okay, so this just goes on over the same stuff. How do plant-based diets fight cancer? Okay, that's a good question, right? So, Thinking beyond meat. For many Americans, hold on. I guess I have to start. Cancer is the second leading cause of death in the U.S., but estimates suggest that as many as a third of cases could be prevented with diet and nutrition alone. The recipe and that's why I recommend people read Patrick Quellen's book, Beating Cancer with Nutrition. Many experts recommend filling your plate with foods that grow from the ground. Decades of research suggests that the best diet for cancer prevention is all about plants. That means lots of fruits, vegetables, and legumes. I think vegetables and legumes, and also whole grains. And they're saying a little to no meat or other animal products. Yet a recent series of articles in the Annals of Internal Medicine calls that into question, claiming that there isn't enough evidence that less meat improves health. The backlash from the nutrition community has been swift, calling the studies flawed and even requesting that the journal retract them. While the new studies have grabbed headlines, the bulk of research still supports eating less meat, says Mayo Clinic Healthy Living Program. This is the thing. Is it the lack of meat or the amount of vegetables? Remember, I've pointed this out. I've explained this. I don't think meat is what's causing the health crisis in the United States. People have been eating meat since before we were even people. Okay? Since before people evolved as human beings, people have been eating meat. They haven't been eating so much meat, but they've been eating meat. Meat is a food that humans consume. I think it's the refined meat, it's the processed meat, and primarily the processed meat. But it's also the lack of vegetables. So for many Americans, meals center around the meat. After all, the Department of Agriculture reports that 222 pounds of meat are sold per person per year in the United States. But when researchers asked nearly 70,000 volunteers about their diets, then tracked them over time, they found lower cancer rates among people who didn't eat meat at all. Okay? Why is that, though? Okay, in fact, vegans, those who don't eat any animal products, including fish, dairy, or eggs, appeared to have the lowest rates of cancer of any diet. Next in line were vegetarians who avoid meat but may eat fish or foods that come from animals. Well, really, pescatarians aren't vegetarians. That come from animals such as milk or eggs. But it's important to note that eating meat or not wasn't the only difference between people who didn't. So eating meat or not wasn't the only difference between people who didn't get cancer. People diagnosed with cancer also had a higher body mass index, meaning they were fat, and were less active. That's another thing. People that follow vegetarian or plant-based diets tend to be more health conscious, allegedly, although that's not what I've seen. Plant-based cancer prevention. The natural question, are vegetarians more resistant to cancer because they don't eat meat? Or is it because of what they eat instead? That's my point. Is it because they don't eat meat, or is it because what they eat instead of meat? It's true, plant-based foods such as fruits, vegetables, legumes, nuts, and whole grains are packed with nutrition, and research has also shown that eating lots of them is linked with lower cancer rates. An explanation: plants produce many phytochemicals that may protect cells from damage. Phytochemicals have many beneficial effects, including that they are anti-inflammatory. Another way plant-based foods may prevent cancer is by boosting fiber consumption. Young women who ate the most fiber-rich diets, so again, they ate the most fiber-rich diets, were 25% less likely to get breast cancer later in life. Other research finds that each 10 grams of daily fiber could lower the risk of colorectal cancer by 10%. Or it could be even simpler still, suggests Morad. When people eat more plant-based diet, they naturally consume fewer calories. So this is the calorie restriction thing, which helps them maintain a healthy weight. Vegetarians are less likely to be overweight. a known risk factor for some types of cancer. The impact of meat on cancer rates. If it's all about loading up on phytochemicals and fiber, meat lovers may be tempted to have their steak and salad too. So have your steak and salad too, but research also suggests a link between meat and cancer. In one review, this is the thing, I'm iffy with that because it really seems to be primarily the processed meat, and also you do have to take in consideration other variables. In one review, each additional 3.5 ounces of red meat a day raised the relative risk of colorectal polyps by 2%. Just half as much daily processed meat, such as deli meats or hot dogs, raised the risk by 29%. So this is what I mean by that. So 3.5 ounces of red meat raised the risk by 2%. However, half of that, which would be like 1.25 ounces, in processed meats, such as deli meats and hot dogs, raise the risk by 29%. So that's 2% versus 29%. Okay? And if it was the same amount, it would be 58%. You get what I'm saying? That if it's dose dependent. So what's the problem with meat? Eating more of it has been shown to increase the risk of dying from all causes. This is true. A key reason: chemical compounds created when red meat is cooked. Again, this is how it's cooked too. If you're steaming your red meat or if you're boiling your red meat, like stewing it, these compounds aren't necessarily created, are thought to be cancer-causing compounds, in processed meat also seem to contribute. The less red and processed meat you eat, the better your health. But what you have to understand, that 2% increase, okay, number one, you could eat less meat. That's number one. Number two, you could avoid processed meat and load up on the vegetables. Like you could avoid processed meat, avoid deli meats, avoid hot dogs, load up on the veggies. You got what I'm saying? And maybe reduce the red meat with like a Mediterranean-style diet. I promote a plant-centered diet, obviously. Okay, eating more of it has been shown to increase the risk of dying from all causes. Okay, the less red and processed meat you eat, the better your health. But as you see, look at the difference between the risks posed by red meat versus processed meat. It's much lower for red meat than processed meat. So Morad says a good guideline is to eat no more than 12 to 8 ounces of red meat or processed meat a week. 3 ounces is about the size of the palm of your hand. Okay, so experiment with meatless meals, use beans for bulk. I recommend a legume-centered diet. Now, what I want to recommend, what I want to suggest to people, what I want to tell people, I'm not a doctor, I'm not a dietitian, I'm not a nutritionist, I'm not a nurse, I'm not an LPN, and I'm not an RN, I'm not a chiropractor, I'm nothing like that. But following the research, I would personally, which I do personally, eat a legume-centered diet. Treat meat like a condiment. That's been said for decades, okay? Use meat to add a little bit of flavor, okay? So I'm going to move on now. Vegetable-based dietary patterns and liver cancer risk results from Shanghai women study. Now, one thing I want to go over, and I want people to follow this, but I'll show you. The good thing is this takes into consideration smoking risks and all that stuff. But I'm actually going to just go to the results. You can read this on your own if you want. Cohort members who developed liver cancer were older and more likely to have a lower educational level. This is from China. Prior to history of chronic viral hepatitis, chronic liver disease or cirrhosis, okay, blah, 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 okay, cases were more likely to have higher BMI and lower vitamin E supplement use. Okay, again, this is the importance of antioxidants, a history of diabetes and high vitamin C and multivitamin supplement use, no differences in total energy intake, smoking habits, alcohol consumption, or regular physical activity in the preceding 5 years, baseline characteristics of the Shanghai Women's Health Studies, liver cancer cases compared with other cohort, baseline characteristics of participants of quartile age and energy-adjusted vegetable-based dietary pattern are presented in and it's in a table there. Okay, in the highest quartile of vegetable-based dietary pattern were young. These are study participants in the highest quartile of vegetable-based dietary pattern were younger, more likely to have a higher income, higher education, higher BMI, and a higher a history of diabetes and a history of were regular, but they were regular exercisers and alcohol drinkers, and fewer were manual laborers. See, that's important. Exercise matters too. In addition, women in the highest quartile of the vegetable-based pattern were more likely to be smokers. So the women that were in the highest amount of vegetable consumers were more likely to be smokers and have lower total energy intake, meaning they ate less calories and they were less likely to be married. Men in the highest quartile of vegetable-based pattern were more likely to be non-smokers, married, have higher total energy intake, meaning they ate more, and a history of chronic liver disease or cirrhosis. The fruit and meat-based dietary patterns also varied according to this. So you have to take into consideration everything. The vegetable-based dietary pattern was inversely associated with liver cancer risk. The vegetable-based dietary pattern was inversely associated with liver cancer risk. Okay? So that's what you have to understand. Further analysis, including individuals with a family history of liver cancer, showed little change in the risk, blah, blah, blah. So hazard ratios for liver cancer risk, a quartile of dietary patterns in Shanghai Women's Study, blah, blah, blah. So what you have to understand is, once more, the vegetable-based diet was associated inversely with liver cancer. That's what we need to look at here. So it's not added fiber. They also took into consideration the smoking and the drinking and the exercise patterns and the work history and environmental exposures. These are all important factors too. Effects of vegetarian and vegan diets on gut microbiota. This is interesting here, how plant food components influence gut microbiota. So a lot of people say that, eating intact foods decreases bioavailability. This is also why I encourage cooking foods to increase the bioavailability of the nutrients. But consuming food nutrients with low bioavailability has recently been found to be important. Lower nutrient bioavailability found in larger food particles, intact plant cell walls, and food without thermal treatment means that more nutrients reach lower in the gastrointestinal system, thus enriching nutrient delivery to gut microbiota. This helps support normal gut microbiota. Modern westernized diets contain more ultra-processed foods and acellular nutrients, or nutrients not containing cells. These components are more easily absorbed in the small intestine, depriving the colon of important nutrients, which may alter the composition and metabolism of gut microbiota. Carbohydrates. Unlike digested carbohydrates, non-digestible carbohydrates such as resistant starch and some sugars reach the large intestine, where they can be fermented by gut microbiota to provide energy or produce postbiotics. However, both digestible and non-digestible carbohydrates may influence gut microbiota. Digestible carbohydrates from fruit have been shown to reduce bacteroides and Clostridida. Non-digestible carbohydrates most consistently increased lactic acid bacteria. Both digestible and non-digestible carbohydrates have been shown to increase by phytobacteria. These are what are called probiotics, but this is why I went back to eating prebiotics as opposed to taking probiotics, because taking probiotics can cause dysbiosis. So participants consume both a standard enteral formula and a formula supplemented with fructo-olga, whatever. It's a type of fiber that's resistant to digestion. FOS and fiber are both forms of carbohydrates found naturally and abundantly in plant foods. Derek Pearson and Sandy Shaw were promoting this for life enhancement. which is another company they formulate for. While the volume of formula prescribed was based on the individual energy expenditures, a benchmark of 2,000 calories, the average daily intake of fermentable non-digestible carbohydrate is estimated to be 10 grams of inulin and FOS. This amount does not include meals and products supplemented with inulin. So this isn't including meals supplemented with inulin. Okay, therefore, so these are from natural sources. Okay, Bifidobacterium is a butyrate-producing genus known to play a protective role in the human gut barrier by providing defense against pathogens and disease. When participants were given formulas with FOS and fiber, their bifidobacteria increased, blah, blah, so it's protective. While these studies suggest that bacterium increase in response to fiber-rich, high-carbohydrate diet, other studies have shown conflicting results. So that's important to note. One important co-founding factor may be alcohol intake, which has been strongly associated with lower abundance of bifidobacteria. So alcohol consumption causes dysbiosis. That's another reason not to drink alcohol. Research, which is one of the eight Adventist laws of health, which is temperance. Researchers comparing bifidobacteria levels in vegans, vegetarians, and controls found bifidobacteria to be significantly lower in vegan samples than in controls eating a standard omnivorous diet, which is very interesting. No difference between vegans and vegetarians was observed. Another study observed higher bifidobacteria levels in meat eaters, okay, compared to participants who switched to a vegetarian or vegan diet. Okay, that's interesting to know. The prebiotic effects differ due to the type of bacteria that each fiber is broken down. Proteins. A majority of studies have noted that protein consumption correlates positively with microbial diversity. However, animal and plant proteins influence the gut microbiota in different ways. That's important to understand. For instance, individuals consuming high animal protein diet from beef, which is also high in fat, displayed lower abundances of bacteria such as Roseburia, whatever. I'm not trying to read these different species of bacteria that metabolize dietary plant polysaccharides. Populations of bacteria that increase in response to high animal protein diet when compared to subjects consuming a meatless diet are typically bile-tolerant microorganisms such as bacteroides and Clostridida. Additionally, a high-protein diet typically limits carbohydrate intake, which may lead to a decrease in butyrate-producing bacteria and thereby to a pro-inflammatory state. So keep that in mind. A high meat diet can lead to a pro-inflammatory state and an increased risk of colorectal cancer. Individuals consuming pea protein exhibited increases in beneficial bifidobacteria and lactobacillus. These are what are in probiotics. You don't have to take probiotics if you're taking things like pea protein, okay? Fats. Current evidence suggests that both the quantity and quality of consumed fats significantly impact gut microbiota. Okay, a plant-based diet is generally naturally low in fat, which favors beneficial bifidobacteria in human gut. The fat that does come from a vegan and vegetarian diet is made up predominantly of mono and polyunsaturated fat, which increases bacteroidetes, whatever ratio, and on the genera level, increase lactic acid bacteria, bifidobacteria, blah, blah, blah. Nuts, particularly walnuts, have been shown to improve gut microbiota by increasing this bacteria. On the other hand, saturated fat found almost exclusively in animal sources increases biophilia and this type of whatever. Some studies report that this change activates inflammation and inflammatory cytokines and leads to metabolic disorders. Okay, so high consumption of saturated and trans fats predominantly found in a Western diet, so not in a vegan diet that's not in a whole food plant-based diet, but in a predominantly Western style diet, these trans fats and saturated fats increases the risk of cardiovascular disease and reduces beneficial bacteria. N3 polyunsaturated fatty acids. So essentially you're getting, you don't want to get dysbiosis by eating the wrong foods. So eating a high meat diet can whack out your intestinal your microbiome. Polyphenols are naturally occurring plant metabolites in plant foods increased by Phytobacterium and Lactobacillus abundance, which provide an antipathogenic and anti-inflammatory effect and cardiovascular protection. Common polyphenol-rich foods include, I've been over this a million times, fruits, seeds, vegetables, tea, cocoa products, and wine. For example, polyphenol extracts from tea generate an increase in Bifidobacterium and Lactobacillus, which then yields an increase influence of microbiome, postbiotics on human health. Research on gut-brain, gut-lung, and gut-liver axis highlights the importance of the microbiome on systemic human health. Studies note changes in central neural chemistry, inflammatory lung conditions, and non-alcoholic fatty liver disease pathogenesis with changes to microbial composition. The mechanism of communication among these organs stems from the microbial products and microbial metabolites of ingested nutrients. These products can be diet independent, such as lipopolysaccharides, ribosomally synthesized, meaning your body's making them in the ribosome. But here we would like to describe a few examples of well-known diet-dependent metabolites. Okay, depending on the bacteria and the location, be produced to microbiome. Okay, short-chain fatty acids act as a substrate to maintain colonic epithelium and are correlated with plant-based food consumption. Maintenance of the intestinal barrier prevents endotoxemia and the subsequent inflammatory effect. So, although a small fraction can derive from proteins, the fecal levels of these metabolites and their corresponding esters positively correlate with the consumption of fruits, vegetables, and legumes. Thus, their levels significantly increase in people who begin a plant-based diet. Interestingly, an increase in SCFAs is observed when omnivores consume a Mediterranean diet rich in fruit, legumes, and vegetables. While specific gut microbes are predisposed to SCFA production, different bacteria are known to produce different SCFAs. For example, enteric bacteria, such as whatever the hell that is. The protective role of acetate, propionate, and butyrate against different types of disease, such as type 2 diabetes, inflammatory bowel disease, and immune diseases, is well documented. For example, it has been shown that SCFAs promote immunity against pathogens and are important components for microglia function and maturation and control of blood-brain barrier integrity. Other effect of SCFAs is to increase thermogenesis, preventing and treating obesity. SCFAs serve as energy substrates for colonocytes, meaning cells in the colon, as well as for the body generally. For example, propionate serves as a glucogenate substrate in the liver and in the intestine. Microbial interactions with dietary polysaccharides and the resulting SCFAs are important energy and signaling molecules. It is becoming increasingly accepted that butyrate-producing bacteria and butyrate per se may be beneficial for human health. Butyrate has been shown to play a key role in gut physiology as a major carbon source for colonocytes. It helps regulate critical functions of the intestine, such as intestinal motility, mucus production, visceral sensitivity, the epithelial barrier, immune homeostasis, and mucosal oxygen gradient. Phytoestrogens are plant-derived polyphenols that interact with estrogen receptors with either agonist or antagonist actions. A large majority of polyphenols are delivered to the gut. Given their 1% bioavailability, the protective effects of plant polyphenols, particularly their anti-cancer, so plant polyphenols and particularly their anti-cancer, anti-inflammatory, and antioxidant effects, and their association with decreased risks of cardiovascular disease, obesity, diabetes, osteoporosis, and amyloid formation have been observed in humans. Increasing evidence shows that these effects are reached after bioactivation of polyphenols by gut microbiota. Even though plant polyphenols have protective effects on human health, especially in the bioactive form, there is still a possibility of adverse effects due to their complexity of action and potential potential inter-individual variability. While not all types of microbes participating in the polyphenol metabolism are yet known, it has recently been shown that Bifidobacterium, Lactobacillus, and blah, 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 these are popular probiotics, are involved in the process of converting polyphenols to equal. The interaction of polyphenols in gut microbiota is bidirectional. The gut bacteria produce microbial metabolites from polyphenols, which in turn serve as prebiotics for the gut bacteria. These metabolites, particularly urolithians, promote the growth of lactobacillus and whatever. Vitamins. Gut microbiota are crucial for adequate vitamin levels in the human body. Menaquinone, folate, cobalamin, and riboflavin, vitamins K, B9, and B2 are produced by gut microbes. Different bacteria have biosynthetic properties for different vitamins, such as bifidobacteria for vitamins K, B12, biotin, folate, thiamine, bacillus subtilis, and S whatever for riboflavin. So your body produces, the bacteria in your body produce these vitamins. You have to understand that. The pathway analysis, the predicted metagenomes show enrichment of folate biosynthesis in vegans compared with omnivores. Isothios, whatever, are compounds from gluco, whatever, mainly found in plants like cruciferous vegetables. Okay, These metabolites have cytoprotective and antioxidant effects through the regulation of gene expression, regulating toneoplastic, atherosclerotic, and neurodegenerative processes. Ligands, intestinal receptor, blah blah. Plant foods, specifically cruciferous vegetables. Such as from high diet can decrease to 2. Secondary bile acids, a separate group of postbiotics, are cholesterol metabolites. Several bacterial strains isolated from intestine or feces are described to convert dietary or synthesize de novo cholesterol into which is poorly absorbed by the human intestine. Thus, serum cholesterol in host is reduced, which decreases the risk of cardiovascular diseases. On the other hand, bile acids synthesized from cholesterol are converted by microbiota into secondary bile acids found in different tissues and in the feces. It is believed secondary bile acids are involved in the equilibrium of health and disease. For example, they are associated with inflammatory bowel disease. So eating a high cholesterol diet can cause inflammatory bowel disease, liver, and colon cancer. Trimethylene and oxide, or TMAO. People might remember this one. This was a big scare when they discovered this. So carnitine and choline are the precursors for TMAO. I supplement with carnitine. Other research shows that carnitine only does this in the presence of a high-fat animal-based diet anyway. But these... So it's found primarily in foods, eggs, beef, pork, with lower amounts found in beans and fish, have been linked to intake of animal proteins. TMAO levels in general. Meat intake appears to proliferate species of these bacteria, which create higher TMAO levels observed with red meat intake, because red meat is high in carnitine, of course. Vegetarians have a different gut microbiota composition. So this is one of the other things. Do vegetarians have protection from the formation of TMAO? That's another question. In response to carnitine, who knows? But I do know that I supplement with carnitine because of the heart. The precursor to TMAO, the plasma concentrations of TMAO appear to be similar in vegans and lacto-ovo-vegetarians. Lowering TMAO levels may be achieved through greater adherence to the Mediterranean diet, particularly the vegetarian one, rich in fruits and vegetables. Increased vegetable consumption reduces TMAO levels by reducing the enzyme. There we go. By reducing the enzymes responsible for converting TMA to TMAO. So yes, so vegetable consumption does reduce TMAO levels. The studies have shown TMAO production to decrease in vegetarians. which decreases their cardiovascular risk. To be objective, we have to mention a recent study leaving a room for further analysis. Vegan fecal microbiota transplantation in metabolic syndrome patients resulted in significant changes in intestinal microbiota composition, but failed to show changes in TMAO production. On average, 25% of plasma metabolites are different between 25% of plasma metabolites are different between omnivores and vegans, suggesting a significant direct effect of diet on the host metabolome. No unique bacterial taxa have been significantly associated with individual metabolite levels. Conclusion: current research indicates that diet is the essential factor for human gut microbiota. Diet is the essential factor for human gut microbiota composition. What in its turn is crucial for metabolizing crucial for metabolizing nutrients into active for the most postbiotics. Up-to-date knowledge suggests that plant-based diet may be an effective way to promote diverse ecosystem of beneficial microbes that support overall health. Up-to-date knowledge suggests that a plant-based diet may be an effective way to promote a diverse ecosystem of beneficial microbes that support overall health. Nonetheless, due to the complexity and inter-individual differences, further research is required. Okay. This is from NPR. It's called Chowing Down on Meat and Dairy Alters Gut Bacteria a Lot and Quickly. Harvard University scientists have given us another reason to walk past the cheese platter at holiday parties and reach for carrot sticks instead. Your gut bacteria will thank you. Switching to a diet packed with meat and cheese and very few carbohydrates alters the trillions of microbes living in the gut, scientists report Wednesday in the journal Nature. The change happens quickly, within 2 days. The types of microbes thriving in the gut shuffle around, and there are signs that some of these shifts might not be so good for your gut. One type of bacterium that flourishes under the meat-rich diet has been linked to inflammation and intestinal diseases in mice. I love meat, says microbiologist. And that's one of the things that I want to point out. I gave up meat for ethical reasons. A lot of people assume that people that give up meat don't like meat. Not the truth. I love meat. I love the taste of meat. I gave up eating meat for ethical reasons. Doesn't mean I don't like the taste of meat. Doesn't mean that I don't know how to cook. I still cook meat for people. If I'm cooking for somebody that eats meat, I will cook meat for them. I don't eat meat. I won't eat meat. But I do cook meat if somebody wants meat that I'm cooking for. If I'm, like with somebody or something, it's not a big deal. I will use cheese in food if I don't eat it, but I will use it for somebody else's food. But I will say that I definitely feel a lot more guilty ordering a hamburger since doing this work, he said. Okay. Scientists are just beginning to learn about how our decisions at the dinner table or the drive-thru tweak our microbiome. That is, the communities of bacteria living in our bodies. But one thing is becoming clear: the critters hanging out in our intestine influence many aspects of our health, including weight, immunity, and perhaps even behavior. And interest in studying the links between diet and human microbes growing. Previous research in this field had turned up tantalizing evidence that eating fiber can alter the composition of gut bacteria, but these studies have looked at diets over long periods of time, months and even years. David and his colleagues wanted to know whether fiber, or the lack of it, could alter gut bacteria more rapidly. To figure that out, the researchers got 9 volunteers to go on 2 extreme diets for 5 days. The first diet was all about meat, cheese. Breakfast was eggs and bacon. Lunch was ribs and briskets. And then for dinner, it was salami and prosciutto with an assortment of cheeses. The volunteers had pork rinds for snacks. Then, after a break, the 9 volunteers began a second fiber-rich diet. At the other end of the spectrum, it all came from plants. Breakfast was granola cereal. For lunch, it was jasmine rice. cooked onions, tomatoes, squash, garlic, peas, and lentils. Dinner looked similar, and the volunteers could snack on bananas and mangoes. The animal-based diet is admittedly a little extreme, he says, meaning it's a carnivore diet, but the plant-based diet is one you might find in a developing country. So keep that in mind. The plant-based diet is like one you might find in a developing country. Remember the China study. Okay? Remember what Dr. Campbell found, okay? So David and the team analyzed the volunteers' microbiomes. Remember the Blue Zone study, okay? They looked at the microbiomes before, during, and after each diet, and the effects of all that meat and cheese were immediately apparent. The relative abundance of various bacteria species looked like it shifted within a day after the food hit the gut. After the volunteers had spent about 3 days on each diet, the bacteria in the gut even started to change their behavior. The kinds of genes turned on in the microbes changed in both diets, he says. In particular, microbes that love bile and the biophilia started to dominate the volunteers' guts during the animal-based diet. Bile helps the stomach digest fats, so people make more bile when their diet is rich in meat and dairy fats. A study last year found that blooms of biophilia cause inflammation and colitis in mice, but we didn't measure levels of inflammation in our subjects, David says. Instead, he says this team's data support the overall animal model that biophilia promotes inflammation, so basically this is one of the reasons that a high meat diet causes inflammation, which could ultimately be controlled by diet. Our study is the proof of he says our study is a proof of concept that you can modify the microbiome through diet. David says, but we're still a long ways off from being able to manipulate the community in any kind of way that an engineer would be pleased about. Even just classifying biophilia as bad bacteria is a tricky matter. A gastroenterologist at Mayo Clinic in Minnesota. These bacteria are members of the community that have lived in harmony with us for thousands of years, says Kashyap, who wasn't involved in the study. You can't just pick, this is the whole problem. You can't just pick one member of this whole team and say it's bad. Okay, that's the problem, because it's about balance. Most bacteria in the gut are here for our benefit. So when you go back to a diet that's more like the diet of our great ape cousins, more like the diet of those people in developing countries, more like the diet of hunter-gatherers, a plant-centric diet, you start to get bacteria in the gut that looks more like it should probably, okay? But giving the right environment, they can turn on us and cause disease. So yeah, if you give them, if they're out of whack, if there's too many of them, remember, demography matters. Demography matters whether it's society at large or the bacteria in your guts. Too much of certain things can cause a problem. Nevertheless, Kashyap thinks the Nature study is exciting because the findings unlock a potentially new avenue for treating intestinal diseases. We want to look at diet as a way of treating patients, Kashyap says. This study shows that short-term dietary interventions can change microbial composition and function. Of course, figuring out exactly how to do that will take much more research. The paper has made the next leap in the field, Kashyap says. With discovery comes responsibility. Once you make this big finding, it needs to be tested appropriately. And that's going to be all for this video.